welcome back everybody. So today we are going to be talking about vectors. And so let's talk a little bit about what vectors are. So it's a quantity involving magnitudes, as in pounds or miles per hour, can be represented with the numbers called sectors. So these are just regular numbers. And then there's other quantities called vectors that are represented by both magnitude and direction. So you guys may have heard of this before, and it might be from a familiar movie. So give me a second. So that may be where you've heard of vectors before. Or if you're taking physics, you've probably heard of vectors and used them a lot in there too. So let's get back to the notes. Okay, so talk a little bit more about vectors. So a vector quantity is represented with a directed line segment called a vector. And then the length of the vector is called the magnitude. And so we represent magnitude sort of with absolute value. But so the absolute value sign sort of signifies that we're talking about the magnitude. And then there's different ways that we can name a vector. It can be with the initial point, and the terminating point. And so what I mean by that is if we have a vector that goes from O to point P, we could name this OP, where it's going from O to P. We could name it with a V with the arrow above it, or if you see it on MyMathLab or even in the notes, it's just a bolded letter. So those are the different ways that we can see vectors written. And then we can add vectors together, and then vector addition is commutative, so it doesn't matter the order, but we call this the resultant of vectors A and B. Now, if we see this negative V, this is the opposite of V. And then the magnitudes, so the sum of the magnitude of V and negative V is 0 and results in the 0 vector. And so the reason for this is because the magnitude of V is equal to the magnitude of the opposite of V. So opposite vectors have the same magnitude but different directions. Okay, and so then this is how we represent the sum of two vectors. So we could line them up from one end to the other. And then this is the resultant. Or they could be starting at the same position, the same point, and then this is the resultant. And so we get that by drawing a parallelogram. So I have in your notes here some properties of parallelograms that you should know from geometry. So we know that the opposite sides are parallel. The opposite sides are the same length. And then the adjacent angles are supplementary. And so that's this middle one we use a lot, especially that the adjacent angles are supplementary, which means that they add to 180. And then the diagonals of the parallelogram bisect each other, but they don't necessarily bisect the angles of a parallelogram. So when we draw our diagonal, these two angles here are not necessarily congruent. So we will be drawing lots of parallelograms in this lesson, so get ready. So we have two forces of 15 and 22 newtons acting on a point in a plane. Newton is just the unit of force. And then if the angle between the force is 100, find the magnitude of the resultant force. So let's first draw out our picture. So we have force of 22 and 15. And then the angle in between them is 100. So the picture doesn't have to be super exact as long as you have it labeled that one side is 15, the other side is 22, and then the angle in between them is 100. So the thing is we want to make our parallelogram. I'm going to draw this in. So then this side's 15, this side is 22, and then our resultant is the diagonal. And then we know that this angle is 80. And so it has to be this diagonal because, just a note, if we did it that it was this diagonal, it wouldn't be end to end. And so it would end up resulting in a different number. And so that is not the one that we want. So it has to be the one that goes in between the two angles. And so then basically we have this triangle where this is 15, this is 80 degrees, 22, and this is the side that we are trying to find. So thinking back to 7.3, this is side angle side, which means that we want to do law of cosine, where we're looking for the third side. And so then x is going to be equal to the square root of 22 squared plus 15 squared minus 2 times 22 times 15 times cosine of 80. And so then we type all of that into our calculator. And so then the thing is, the reason why I say that this is x is because this is our vector, and then the length, remember that the vector length, the magnitude is equal to the length. So that's x. So we would type all that into our calculator, and then we get that x is equal to 24 newtons. Now, we can also talk about the equilibriant, and the equilibriant of u is negative u. And so again, the reason is it's two equal forces acting on the same point going in opposite directions. So that way the point is staying the same. And so you think about, in order for something to not move, technically it has to have forces acting in either direction to keep it in the same spot. So then again, just restating that the magnitude of u is equal to the magnitude of the opposite of u. So this picture gets a little interesting, so let's take it step by step. We first want to find the magnitude of the equilibrium, but again, it's going to be equal to the same thing. So we just need to find the magnitude of the force. Of the forces, so we want to find the magnitude of the equilibrium of the forces of 48 newtons and 60 newtons acting on a point A if the angle between the forces is 50. I'm going to pause there because we don't quite want to, we want to just take what we have so far. We're not even going to look at the second sentence just yet. So we have a force of 48 newtons and a force of 60 newtons acting on a singular point A. And we know that the angle in between them is 50 degrees. So when we draw our parallelogram to find our resultant, this is our vector v, and this is the equilibrium, which is the same as v, but in the opposite direction. So our forces are the same. The magnitude of v and the magnitude of negative v is the same. And so I'm going to be focusing on this triangle here because I know that this side is also 60. And if this angle is 50, that means that this angle has to be 130. And so then I know that the magnitude of v is just like what we did up in example 1. So we're going to use the law of cosines again. So this is going to be equal to the square root of 60 squared plus 48 squared minus 2 times 60 times 48 times the cosine of 130. And so again, we would type this into our calculator, and we get that the magnitude of v and its equilibrium is going to be 98 newtons. Now, the second part. We want to find the angle between the equilibrium and the 48 newtons. So we want to find this angle. And so in order to find that angle though, we are going to find this angle because we have this triangle. And so I can do, because I now know that this is 98 newtons. So then I can take sine of, and I'm going to call this alpha and this theta. So sine of alpha is going to be, sine of alpha over 60 is going to equal sine of 130 over 98. So if I multiply this 60 over to get 60 sine of 130 all over 98. And then to get alpha by itself, I would need to take sine inverse of this. So then I type all of that into my calculator and I get that alpha is 28. Now, alpha is not the angle we want because that is the angle between the resultant and the 48 degrees Newton. But the thing about this is 180 degrees. So theta is going to be 180 minus 28. So then the angle that we're looking for is going to be 152 degrees. Okay, so this picture also gets a little interesting. So we went to find the force required to keep a 50-pound wagon from sliding down a ramp inclined 20 degrees to the horizontal. Assume there is no friction. And so the assume there is no friction is for all of you people that are taking physics or going on, friction makes everything a lot more complicated. So we were assuming that there is no friction to make it nice and simple. So we have our picture where the ramp is 20 degrees, and then we have our wagon staying the same, and it's 50 pounds. Now, anytime that we have gravity acting on something, it is going to be perpendicular to the ground. Now, the force that we are wanting is the force to keep it steady. So this is going to be the same as this force, which, and so then this is the resultant. And so then these angles are actually 90 degrees because the force needed to keep something in equilibrium and the resultant are always going to be 90 degrees from each other. So essentially, we have this triangle. So this is 90, this is our force. And we know that this is 50. Now, we just need to know one of our other two angles, and then we can just use our regular SOHCAHTOA. So if we do a little looking, if this is 20 degrees, that means this angle has to be 50 degrees, which means this angle, which is this angle, also has to be 20 degrees. So anytime that you have these problems with a force or like a ramp with so many degrees, blah, 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 the angle that it gives you in the problem is going to be the angle that you use in your right triangle. And so then we get that sine of 20 degrees is equal to the magnitude of our force over 50. And so then 50 sine of 20 degrees equals the magnitude of our force. And so then we get that our force is equal to 17 newtons. So I probably should have also said this, but your calculator should be in degree mode for all of this. Okay, so there is no example 4. Basically, we cut it out, and then I forgot to change the number from example 5 to example 4. So we have our 5th example, and this one, again, has to do with bearings. So we have a Shipley support on a bearing of 28. So we have our north axis, we have a port, and so this angle is 28 degrees, and this side is 8.2. Let me write that a little bit better. Okay. And so just for naming's sake, I'm going to call this N. This is port P. We're going to call this A. Then the ship turns due east. So that means that from our north axis, this is 90 degrees, and goes 4.3 miles. And we want to know how far the ship is from port. So the first thing that we're looking for is side A. And so let's start with that. So we have side A, and then this is a right angle, not a 7. So we know that this is 90 degrees. And then we know that this angle would be 28. So if we take 28 plus 90, we would get 118. And so we have a side angle side situation, and we want the third side. So we're going to use law of sines. So A equals the square root of 4.3 squared plus 8.2 squared minus 2 times 4.3 times 8.2 cosine of 118. So we type all of that into our calculator, and we get that A would be 10.9 miles. Okay, so now we want to find what is the bearing from the port. So that would be this whole angle. So I'm going to call this theta, because then we know we can use law of sines. So sine of theta over 4.3 equals sine of 118 over 10.9. And so then theta would equal sine inverse of 4.3 sine of 118 over 10.9, which would give us 20.4. So then our bearing, again, is this whole angle. So that would be 28 plus 20.4, which would be 48.4 degrees. So that is all of our notes for today. I hope you have a great day. Bye.